A concept worth understanding is the MECE principle. MECE is an acronym representing mutually exclusive, collectively exhaustive. Mutually exclusive means that all things are distinctly different. For example, when you flip a coin, it can either land on heads or tails, but not both. Collectively exhaustive means that together, nothing is missed. For example, spring, summer, fall, and winter cover all the seasons. There are no other seasons outside these four. Put simply, MECE is a grouping principle that ensures nothing is duplicated and nothing is missed. Let's start with a very basic example. Say we have 6 Lego blocks. We want to sort this Lego using the MECE principle. We could sort the Lego based on color or shape or the number of studs on each block, but let's sort based on color. Imagine 4 containers: blue, green, yellow, and red. We sort each Lego block into one of these containers according to its color. Is this sorting MECE? Well, let's test it. Firstly, is it mutually exclusive? Well, yes it is, because each Lego block can only fit in one single container. For instance, the green block can only be in the green container. Secondly, is our sorting collectively exhaustive? In this case, yes, because all our Lego blocks fit into a container. None are left on the carpet waiting to be stepped on. Imagine for a moment we had one block that was half green and half blue. Then our model wouldn't be MECE, because this dual-colored block could fit into 2 possible containers. Our model wouldn't be mutually exclusive. Now, let's start over and sort our Lego based on a different property, the number of studs on each Lego block. Let's say we have a container to hold 4 studded blocks and a container to hold 8 studded blocks. This model is also MECE. All our Lego blocks can only fit in one container and no blocks are left behind. Imagine we encounter a new Lego block with just 2 studs. Is our sorting model still MECE? Well, no, because the block with 2 studs has nowhere to go. Our model is no longer collectively exhaustive. We would need to modify our model to hold Lego with 2 studs. Then our model would be MECE once again. These simple Lego block examples consider only one property at a time. But what if we wanted to sort on both color and the number of studs simultaneously? For that, we'd need a multi-dimensional MECE model. Let's put aside our Lego example and explore a different multi-dimensional MECE model. Imagine we are a marketing team with many existing and prospective clients. We want to develop a MECE model to group these clients. Our aim is to have a nice, clear segregation to ensure we don't double up on marketing and to make sure that no clients are missed. We'll start with one property to begin with: existing clients and potential clients. This sounds good, but unfortunately this is not MECE, because past clients don't really fit neatly into either of these groups. Instead, we'll use existing clients and not existing clients. This is MECE because it's impossible for a client not to be in at least one of these categories and impossible for them to be in both. Rather than using X and Y properties to define a segment, we can use X and not X, a positive and a negative of the same property. The not X will ensure our model is collectively exhaustive. We'll explore this further in a second. This single dimension model only segregates our clients by one property. Let's add a second dimension. We could further segment our clients into sells online or sells in store. But this is not MECE, because some clients do both and some clients do neither. Instead, let's use X and not X. In this case, sells online and doesn't sell online. This is MECE. So now we need to combine our two dimensions into one model. It will look like this: existing clients who sell online, existing clients who don't sell online, not existing clients who sell online, and not existing clients who don't sell online. Because this model is MECE, every client we encounter can be sorted into this model without exception. As a marketing team, we can now divide our efforts into these 4 segments, knowing we won't double up and that no clients will be missed. Now, this is a fairly simple model. If we wanted to capture more complexity, for example, to have a segment of past clients who only sell over the phone, we would absolutely have to extend our model. And we could, so long as we continue to apply the MECE principles. Let's look at one more example, how we can apply MECE to improve ideation. Imagine we need to solve a problem. We run a brainstorming session and come up with a collection of ideas. Now, we need to refine these ideas. Our goal is for each idea to be distinctly different from all other ideas. No overlaps, and to capture as many ideas as possible, no gaps. To do this, we can use the MECE principle. Firstly, let's check if our ideas are mutually exclusive. For this, we can ask, have we repeated ourselves anywhere? Are any ideas too similar? If any 2 ideas are similar, we should eliminate one or more clearly define both ideas so we don't have any overlaps. Next, let's check if our ideas are collectively exhaustive. For this, we can ask, have we missed anything? If an idea is limited in its scope, we may add another idea so we have as few gaps as possible. By applying the MECE principle to our collection of ideas, we end up with a clean list of distinct ideas, making them far easier to action. Plus, we expand our thinking, which provides more potential solutions to our problem. The MECE principle is a powerful tool because it ensures that all aspects of a problem or situation are considered without any overlaps or any gaps. We've seen how we can use the MECE principle to create grouping models that are both mutually exclusive and collectively exhaustive. We've also seen how we can use MECE to enhance our ideation processes. Whether sorting Lego pieces or categorizing clients, the MECE principle leads to more efficient problem solving and better decision making. By understanding the MECE principle, you hold a powerful tool that brings clarity and order to complex situations.